1, 2, 3, 4.
Smoke from the combustion of fossil fuels, such as gasoline or coal, are the main causes of acid rain in America. Though studies from National Geographic and Pace University show that this is the main source of acid rain, it is not the only. Pace University also says that bacteria in the waste of livestock is another cause. Also, inorganic fertilizers. According to the same study, natural causes can play a smaller role. Natural disasters such as forest fires, volcanoes, and lightning. The diagram displays, along with some of the different sources of acid rain, also the areas that it affects and two of the major chemicals that are involved. According to Pace University, of the 20 million tons of sulfur dioxide released into the atmosphere every year in the United States, 3/4 comes from fossil fuels burned by electric utilities. Acidic pollutants are formed by sulfur and nitrogen fumes being emitted from smokestacks. Nitrogen-oxygen compounds also play a big role. The same study shows that 78% of the atmosphere is made up of nitrogen, but 80% of that is man-made. Sources such as burning fossil fuels. The other coming from denitrification of soil, mainly. These nitrogen oxides are mainly from fuel combustion from vehicles. According to National Geographic, sulfur dioxide and nitrogen oxides released into the atmosphere react chemically with water and oxygen. The solutions formed, sulfuric and nitric acid, are spread over hundreds of miles across the atmosphere by wind. Acid rain is classified on the pH scale. Regular water is classified as 7. Rain before the Industrial Revolution was between 5 and 6. The phrase acid rain is now used to describe rain with a pH below 5. According to Ohio State University, acid rain lowers the pH of lakes. When a lake's pH dips below 6, basic forms of food such as mayflies and stoneflies die off because they can't survive at that pH level. When it begins to creep below 5, the fish population starts to die off. The EPA states that some lakes can even have pHs as low as Little Echo Pond in Franklin, New York, which has a pH of 4.2. The same article states that trout and salamanders begin dying off when the pH dips below 5. Frogs will survive to a pH about 4. Perch at 4.5 begin dying off. Also, according to Ohio State, acid rain will release aluminum in the water, which can be highly toxic to the life. National Geographic also says that acid rain is harmful to forests, particularly high elevation forests. The acid leaches the soil of its nutrients and releases aluminum, which makes it difficult for the trees to take up water. The leaves of the trees are also affected by the acids. This can leave entire sections of forests bare, as you can see by the pictures. Acid rain also affects the tree's immunity to such things as cold temperatures, insects, and disease. The tree's abilities to reproduce are also affected. The same study states that the soil's buffering capacity, or ability to neutralize acid, is immediately dependent on how much the trees are affected by the acid rain. Some soils neutralize acids better than other soils. Areas with low buffering capacities are harmed much more easily. Acid rain also erodes away at limestone and marble. According to Pace University, the calcium carbonate in the stone is dissolved by the acid. When this solution evaporates, crystals are formed. When these crystals grow, the stone breaks apart and the structure begins to crumble. Architecture that has been affected includes the Taj Mahal, and the Acropolis. Corrosion can be accelerated by acid rain because of the way it forms a layer of moisture on the surfaces that are metallic. Being that acid rain's biggest contributors are fossil fuel burning factories, automobiles, and coal burning, heavily populated cities and industrial areas see the greatest effects. Cities such as Boston, Philadelphia, New York, and Baltimore. Detroit as well. This map shows the pH of the rain around the country measured in 1998. Notice that the eastern half of the country, the Northeast especially, is the area with the lowest, most acidic pH. The video clip after the map helps explain the topic and offers some insightful solutions.
To generate the energy needed in industrialized societies, vast amounts of coal have been burned. When coal burns, it gives off great quantities of heat energy and smoke. Smokestacks, such as this one, emit so much smoke into the atmosphere that gases in the smoke are changing the very nature of clouds, causing a corrosive form of precipitation known as acid rain. Sulfur dioxide from burning fossil fuels and nitrogen oxides from automobile exhaust fumes react with the water vapor in the atmosphere, producing acidic vapors that mix with the clouds. When the wind blows, these acid-bearing clouds may be moved hundreds of kilometers away from the source of the pollutants. The acid rain that results is damaging to water, forest, and soil resources, and can corrode metals and the surfaces of buildings. One way to address the problem of acid rain is to stop burning high sulfur coal. Coal with less sulfur releases less sulfur dioxide. Another solution is to equip coal-burning power plants with scrubber technology. Scrubbers are placed in the smokestacks and force the sulfur-laden smoke over suspended alkali particles, such as lime. The sulfur oxide reacts with these particles to form an ash that can be removed from the stack as a slurry or powder. Scrubbers can remove up to 95% of sulfur oxides from smoke before it reaches the air.